How about now? Can you hear me?
Yeah.
Yeah.
Okay, perfect. All right, perfect. Thank you for that introduction, Kevin. As he said, my name is Joe Sesto. I'm the chief engineer over here at the Sussex County MUA in northern New Jersey. Just to start this case study, I wanted to provide everyone really an overview of the presentation itself. So just real generally, the overview will be a quick background of the facility, basically the type of flow we're receiving, when it was installed, all that good stuff. Then a timeline of the operation and some of the issues that we encountered. Then just an overview of the plant operation, more of a detailed overview of really where some of the pitfalls were with the original equipment that was installed. And then a review of the considerations for a retrofit versus a replacement in kind. So a review of the operational improvement alternatives. Basically, did we have other options? And you always have other options. So I want to kind of review what we looked at. And then ultimately, the installation of the Kubota membranes, in a overview of the construction, including some photos of the construction, and some final conclusions for the project. So, like I said, initially, I just wanted to provide everyone kind of the backdrop of this facility. So it was installed in November of 2016. The average daily flow is about 50,000 gallons per day. The registered peak flow is 97,000 gallons per day. The design maximum was 170,000. And the daily permanent limit was, was 200,000 gallons per day. Obviously, we're not even, our average day was not even anywhere close to the design maximum for the facility. Then next up, I just wanted to review really what the mixed liquor and the influent ammonia was. Mixed liquor, you're around 10,000 milligrams per liter. Influent ammonia was a little high at 50 milligrams per liter. But really what I wanted to show here was that, it's typical residential wastewater. We don't have really any industries that feed into this plant. We do have a insurance company that feeds in. They're one of their corporate headquarters. But, for the most part, you're not seeing anything unique for the wastewater that this facility sees. And I also wanted to show you that, looking at the MLSS range, we're pretty much in the sweet spot there. There's no issues with it being too high, too low. Just want to kind of paint the picture that, there's not much that's unique here for the incoming wastewater characteristics. The discharge to the facility is just to on-site groundwater disposal beds. There are 5 membranes for this facility. And what's unique and what really makes operational maintenance and any type of retrofit more of a challenge is that there's only one train. So that is something I think that's fairly unique here, is that you don't have any redundancy. You're not able to take one train offline, do any type of maintenance that's required, or a retrofit or an upgrade, whatever you want to do, and then keep the facility online. Any type of work, you really have to isolate the whole plant and then haul, which obviously has a cost that's associated with that. This is a brief overview of the MBR train. So there were 5 units installed. There was a spot for a future 6th unit if we needed additional treatment capacity. We did have a membrane soak tank, which is really if we needed to do kind of a extended clean or a recovery clean, we would be able to use the overhead crane and lower it into that soak tank. One of the other things to really note, well, obviously you can't tell in plan view here, is that all the connections are actually under the water level. So this was really a huge issue in terms of performing any type of maintenance on this equipment. So in order to do any maintenance, you at a minimum needed to lower the water level such that you could unhook the flanges, which really had its own issues with how tight those were. And also there was 4 pick points for these units. So again, you had to lower that water level to even access those pick points. So really any type of maintenance that was required really was a pretty extensive effort based on the fact that everything was underneath that water line. So at a minimum, you needed to reduce that water level, and at times you needed to really drain it all the way down. So from a maintenance standpoint, these are things that we identified once the plant was in operation that in the future we were hoping to correct. So real brief initial timeline from really placed into service to when we had to issue an emergency declaration. So the plant was placed online in November of 2016. The manufacturer came out, a little under a year later to perform the first cleaning, which was all part of the original contract. Then you see a few times, the MUA cleaned as required, looking at the TMP or the permeability. In October of 2018 was really when things started to go downhill. So originally we had issues with the diffusers below the membranes. So in October of 2018, originally that air line was hooked up to a plastic elbow that then obviously provided the air pattern through the diffusers. So it was determined that we were getting a real sporadic air pattern, and it was determined that there was some solids got through this plastic fitting and clogged up the diffusers. So in October of 2018, the manufacturer came out to the site. They replaced all the diffusers. They replaced that plastic elbow piece with a stainless steel metal piece. And that the intent of that was that going forward, you wouldn't have that same failure location. So March 2019, we again were seeing an issue with an increasing transmembrane pressure, a decreasing permeability. In May 2019, so that's not too long after that repair was made, under a year, obviously, we were having the exact same issue that was affecting plant operations. So air was only getting to about the first 25% of the membranes. So 75% we're seeing no air at all. So that inconsistent air pattern then would obviously lead to sludge caking and ultimately to possible tearing and poor operation. At this point, due to really necessity, we had to remove the manufacturer provided diffusers and go to more of a coarse bubble aeration method. And obviously, that provides a lot more air to try to reduce that sludge caking, but I understand it's not really ideal for operation. But this was really done due to the emergency of the situation and the hauling that was required, because not having that aeration, the vacuum pressure was increasing, which was causing plant shutdowns. The plant shutdowns would then lead to emergency hauling. So that occurred in May 2019, and then pretty shortly after, in July, the cleaning in general, the maintenance clean, the extended cleans, the intensive recovery cleans, they were no longer producing the results that were required to maintain the type of flows that were required to really operate. And then again in May 2020, we had to issue an emergency declaration. So that was in just real brief kind of what the overview was of kind of the timeline of the facility. So that goes into what this facility was just operational in November of 2016. Why such a, really, when you look at the grand scheme of things, if you're looking for a 10-year life, why after just 2 years are you seeing this type of reduction in the treatment capacity? So as I kind of alluded to or mentioned in that timeline, in October of 2018, it was confirmed really or admitted by the manufacturer that there was a flaw in the original diffusers. And that led to those diffusers just being packed with sludge, which then led the membranes to be very heavily dewatered. And that significant kind of issue happens, and then there's a big drop in the membrane permeability, which then ultimately correlates, which all correlates back to the failure of the diffusers. And then, like I said, during the last slide, that occurred, the replacement occurred in October of 2018, and ultimately, the diffusers were, even the replaced diffusers were then swapped out in May of 2019. So the original diffusers that were provided, they were made from polyurethane. They're ultrafine bubble, high efficiency diffusers. But as soon as any type of sludge gets through any piece of that, it makes it so they clog extremely quickly. So, even when the piece was replaced, yeah, we were able to get right back to, a transmembrane pressure that we could live with the operation. But as soon as, anything got in, the TMP, really spiked to a point that we really couldn't operate anymore. So year one, everything looks pretty good. You're looking at, a transmembrane pressure between, 0.5 and 0.9. That's in a pretty good range. Like normally, like a good operating range is anywhere up to like 1.5 psi. That's what I've found, and that through speaking with other manufacturers, that's a pretty happy range. So year two, okay, so we did replace, some of the, the existing equipment, or the manufacturer came in, they replaced the existing diffusers, the elbow, all that stuff. So, we're doing okay. You're still at that 0.8 psi. You're in that happy zone still. You're starting to creep up though. 2 psi. You're still doable. 2 psi. I mean, you're still, maybe you're out of that good range. You're in like kind of an okay range. Well, now year 3. I mean, now we're at, we're increasing to as high as 5.8 psi. Well, now that's a critically high range. You get to the point that obviously your permeability decreases proportionally to your transmembrane pressure increasing. So now that our TMP is increasing, our permeability is decreasing. Now we're concerned over pulling solids through the system due to that extremely low permeability of these membranes. And I know, I caught some of the last presentation, and you're looking at, all the cleaning procedures that you can do. So you're looking at, the, maintenance cleans. You're looking at maybe a 2 or 4 hour soak, and then you got the extended clean, and maybe soak it a little longer, 4 hours, 6 hours plus. And then you may want to have an acid clean as opposed to a hypo clean. And then you have to go even further. If that's still not doing it, you got the extensive recovery clean, where you have a higher concentration of the hypo, and then you have a longer period of soak. So all of this was putting a lot of unnecessary strain on these units that are still only a few years old. We're only 30% into what the anticipated useful life was. So I wanted to provide you a real quick photo of just a couple of the units that were removed from the facility. So these are those ultrafine bubble diffusers. If you look on the photo on the right, you can see where that little circle is for that left diffuser. That's where the air comes in, and for that particular unit, it pretty much clogged right after that. So all that brown, the discoloration, that is solids, and if you were to touch it, it's very hard. So you can't actually, there's no way for that air to really surpass those clogs. Pretty much it's going to go as far as the air can go until it reaches that point. And then, you can see it pretty clearly in the one on the right. You have about a third of that diffuser is still operational. Again, you can't tell in the photo, it's tough to see, but as soon as you get to that dark color, that's packed, solids. There's, it's not just like a discoloration on the top. There's actually like a lot of solids that's inside that diffuser. So that's, I really want to kind of illustrate what I'm talking about when I'm talking about the air pattern. So next up is we're at the point now that, prior to the emergency declaration being made, we were looking at options, a replacement in kind, a retrofit, doing more inspections, bringing the manufacturer in. We were doing really all that we could to see what we could do within a certain schedule, within a certain budget. So when we're looking at a retrofit, we really were looking at a few major things. This is a brand new plant. So this plant is only from November of 2016. And keep in mind, the emergency declaration was issued May 2020. So when we're looking at this is to us a very new facility. So looking at the construction obstacles, we had all of this equipment tailored to a certain manufacturer. So we wanted to make sure that we weren't going to have to get all new equipment. When you're looking at the existing crane, existing pipe penetrations, utilization of existing air supply and permeate piping, the pumps, the blowers. We wanted to make sure that, when you're looking at possibly changing manufacturers, we wanted to make sure that we could still use that equipment. Because now if you're starting to repipe, large spans, you're looking at new blowers, new cranes, those are big cost items. Operational improvements. We wanted to make sure, as I spoke about earlier in this presentation, we had to lower the operating level anytime we had to do any real maintenance on the equipment. That then reduces the amount of flow that you can bring into the facility. We want to eliminate any type of downtime associated with maintenance or associated with a retrofit itself. We want to move any type of connections above the grading. Again, right now, everything was below the water level. We wanted to bring everything up. We also wanted to be able to remove the membranes from the flow without shutting off the plant, or at a minimum, not shutting off the plant, and obviously not lowering the water level as either. And then we also wanted to look into possibly having a gravity, clean in place system. So those are all things that we really looked at. And then looking at, again, schedule and cost. I think for all MUAs, all clients in general, you're looking at, you're in a situation where you're hauling during flows really above 40 or 50,000 gallons per day on a plant that was designed for 180,000 gallons per day. So, you want to limit the hauling. So you wanted an expedited schedule. And not only that, you wanted to make sure that when it went to install it, you weren't down for an extended period of time, because we only have one train. So you only have one train, so you're down 100%. So each day that adds to the overall cost of the project. And then obviously cost, not just for the cost of the equipment, but the overall cost, the cost of the hauling, the cost of, really the entire cost in general of the project. Keeping in mind that this facility is still very new. So we evaluated multiple manufacturers, but I really just wanted to speak about the existing manufacturer and Kubota. So when we evaluated this, I'm going to go with the existing manufacturer first. So it was determined by the existing manufacturer and their attorneys that the existing equipment was determined to not be under warranty. And that was for a couple reasons. One was because, we went from fine bubble to coarse bubble. That's outside of the, what's allowed by their O&M manual. But again, that was done out of necessity. And then the other thing was that the data package that was provided didn't track all the required kind of O&M parameters that were required to determine if it was a faulty piece of equipment or faulty operations. So, it's kind of a gray area there, but unfortunately, what was provided with the equipment did not meet what was required for their warranty. So after that was determined, the manufacturer recommended that we drain the train and that they come out to inspect the units on site. So that would really mean that, they would look, see if there's no physical damage, that the permeability had potential to be recovered, and then they would require us as operations to try to remove any of the air blockage within the diffusers. Obviously, as you kind of saw in the previous slide, it was difficult for anyone to really remove the solids that were within those diffusers. So that was all tough to do. And then again, we're looking back at cost, we're looking back at schedule. This all happened during the peak of the pandemic. So there were travel bans for companies. They couldn't cross state lines. So it was a kind of an unknown duration of when they could even arrive on site. And then again, you don't want to throw bad money after bad money. So, we want to make sure that, we're able to rectify the issue and do it in as expedited a manner as possible. So after we kind of went back and forth on the inspection, we ended up we decided to not elect to do that due to the time and the cost that was associated with it. So then we're really looking at the replacement of the existing units. And that's when we're really looking at now bringing in, these other manufacturers, one of which is obviously Kubota. So, again, we had 5 membranes in there. Currently, we wanted to put in all 6. We wanted to use that spare slot to put that 6th unit in. The one thing that was a little concerning for the MUA, or there's really two things here, was that there was no local, really certified installer or installer that had a lot of experience with these guys. So, to try to save costs and, try to do it as efficiently as possible, they recommended that the MUA staff actually provide the labor. So when you're looking at that, it's kind of a liability concern and it's a warranty concern. So we were hoping to really get a turnkey system at the end of the day that's able to, be under warranty, and that's what we'll talk about right now. We wanted to make sure that any changes that were made we wouldn't have the same situation we were in previously of maybe the warranty not being valid. So one of the things I didn't mention is that we're hoping to go to more of a gravity feed CIP system. If we were to proceed that route with the existing manufacturer, that would void the warranty because you wouldn't meet the required flow rate for that chemical fill rate to maintain that warranty. So that 5-year workmanship warranty, most likely would not be valid, even if we were able to upgrade our computer system and the monitoring controls really to track some of the other parameters that were required. If you don't meet, that flow for the CIP, then, that wouldn't matter. Again, the other thing we were talking about was removing basically all the fittings above the grates. That wasn't going to be possible with the existing manufacturer, and also the single pick point also would have been an issue. So we would have gotten new units, but some of the other wish list items were a little bit of a concern, and the fact that the MUA staff would have to do the installation, was included in the decision-making process. So the overall cost was just over $230,000, but that did exclude, again, the miscellaneous piping and tubing, some of the piping modifications that were required. We needed a new airflow meter because the existing one from the original installation had already died, and the actual installation crew, the installation labor. So looking at the other side of the fence here, we looked at the full system replacement with Kubotas, the SP300s. So their proposal included basically all the necessary appurtenances, the diffusers, rails, piping, tubings, fittings, everything. All the modification to the existing piping, such that all the disconnects, the flanges, were above the grate line, so the permeate, the air supply, which is again a huge. It's not just a health and safety issue, but it just makes the operations and the maintenance that much easier to have everything above the water line. Also included in the airflow meter we needed, and we end up going with air freight. We really evaluated. Well, we're under an emergency right now. We needed these here ASAP, so we got expedited shipping and really everything else that we had. And then warranty. Again, we were looking at not just the schedule, not just the cost, not just the operations, but the warranty. If anything were to happen in that 5-year warranty period, is it going to be maintained? So, through discussions with Kubota, as long as we had the appropriate concentration and the volume that's required for these CIPs, that the gravity fill CIP was approvable to maintain that warranty. So really, it was like as long as you got your 400 gallons or so with adequate pH and chlorine concentration, that's all you really need. And then the cost, again, now it's $255,000. So a little bit more than the existing manufacturer, but you get a lot more for that. You really crossed everything off the list, and you had an active warranty that you were comfortable with. So now we're looking at the timeline for Kubota. So early February was when we first contacted Kevin Crane. We do have some experience with Kubotas. We do have another plant that uses their membranes as well. So we are very comfortable with them. Just 4 days after that, the initial contact, we did receive a rough layout drawing, but there was still a lot of unknowns, which made retrofit maybe not feasible. looking at possibly getting, again, new crane, new penetrations, new everything. So it took a while to kind of work through the process, not just with Kubota, but with the other manufacturer as well. We did receive the final proposal mid-May, and then just one day after that, we approved that proposal. So really, you really have just between May, which is when the emergency declaration was issued as well, to early September. So that's a very tight time period when you're thinking about not just you're retrofitting the whole system, the whole plant, but you're also in the peak of a pandemic. So that's one thing that we're still living with that today, but it was a remarkably quick turnaround, and that was very important to us because we were hauling every month, and now it's like $10,000, $15,000 a month, and that adds up over time, and obviously adds to the O&M of the facility. So this is a mock-up of the plant, or of the retrofit. As you can see, the permeate and the air lines and everything are above the grate line. You see the new guide rails, you see the new units. So really, in general, I thought this was just a great representation of the installation. And again, it just shows the single train. So now we're looking at the construction. So that, I think when you look at photos, I think it really tells a story. So when you look at the photo to the right there, or really the only photo on the screen, you see all that sludge that's all over the membrane units. So you see, like, you're probably not getting great treatment, or you're not getting as much flow as you'd like through these because they're just totally caked up. And again, as part of the process, we wanted to make sure everything was as clean as possible before we removed the membranes from the facility. We wanted to keep everything within the train such that we could haul that to one of our other facilities. So really, that first day, the MUA, drained everything. We cleaned out the chamber, and then the manufacturer proceeded to remove the units. They began relocation of the permeate header. They capped any future unused connections, and the new membranes were delivered to the site. And again, when you're looking at this, you're looking at, well, what are my obstacles? In this, I want to kind of go back to what we talked about earlier on in this presentation, the construction obstacles, reuse of the crane, utilization of the existing penetrations, utilization of the existing air supply and permeate lines, the existing blowers, all this stuff. This is all important to note that there was all able to be worked through and to still keep the cost as efficient as possible. So this is the photo on the right. It's just a photo of the removal of the existing units, and the photo on the right is basically once the existing unit was removed. That's a photo of basically the inside. It shows the new, or the retrofitted course bubble and diffusers. Construction day 2. So as you can see here, you're looking at the photo on the left is all the units that were removed. The photo on the right is basically all the the new anchors, the guide rails, everything has been installed. That includes the new guide rail plates, the non-shrink grout, the anchors, everything. There also was some minor adjustments that had to be made to some existing steel beams to accommodate the new equipment, but nothing that could not be managed. There's just when I'm talking about kind of the operational, basically looking at the permeate header. So the photo on the left shows the permeate header. It shows it penetrating through that chamber, and obviously tying into the existing membranes. So that's, that's all below the water line. Photo on the right shows we utilized the existing header. We just modified some of the connection piping. This enabled us to, again, have all the tie-ins above the grates, which again greatly improves how we can operate and maintain the facility. And we did add some valves here and there to be able to prime the system and be able to, to operate, because there are periods of downtime, but we don't have any issues repriming this system, even with the elevated piping now. So other than that, on that day, they did install 2 new units. So we were able to, really see the contractor was amazing here. It was great that they were recommended by Kubota. They had pretty much a small army, and they had people, and everyone had their own task. So, people were working on the permeate piping, the air piping. People were working on the installation of the new units, and everything just went very seamless. On day 3, they completed the installation of all the anchors for the ones that hadn't been installed yet, and they installed 3 additional membranes. So the photo on the left shows the train being completely cleaned and completely done prior to the new units being installed. So again, it went pretty smoothly. We did have one I-beam that was a little bit in the way. We did have to grind that down a little bit, but all locations other than that first one went in very seamless. So this shows, again, the one on the left shows the actual installation within the chamber with that treatment train. Photo on the right just shows, again, one of the units being brought in. That's after it's been picked by the lull outside, and now it's actually hooked up to our existing overhead crane. So again, now the last of the membranes were installed. And this is one of the real big things. We witnessed the use of the Kubota lifting tool. So one of the operational things and the maintenance things we talked about was having a single pick point. Well, that ended up not being feasible. And we also talked about keeping everything, keeping that pick point above the water line. Well, unfortunately, that wasn't feasible as well for either manufacturer. But to combat that, what was designed was an extension of the guide rail pipes that actually this lifting tool would slide down, and it automatically hooks to the existing pick points, the 4 pick points on the membrane system. So although you didn't see it above the water line, you saw the guide pipes above the water line. So you were able to coordinate, you're able to see where this lifting tool needed to go, and then it would just ride down the guide rail pipe and tie into the system. So what are the 2 things? The 2 things were to not have to lower the operating water line to remove one of these units. Well, now we have this lifting tool that we didn't need to do that because the guide rail is seen above the normal operating level. And also we had all the flangers now are above the grates. So we're able to disconnect everything above the grates and then just work this lifting tool down. So this was really a slam dunk for what we needed to just maintain safe operation and maintenance of these units. So on day 4 was when we began to start to refill the facility. So it took, and that started around 1 o'clock in the afternoon. So we started Monday morning at 8, and on day 4, really day 3.5, we were able to get this plant back up and running, which I think is amazing. It really is a true testament of the coordination between the manufacturer, who in this instance would be Kubota, one of their installers, and the MUA staff. So again, this just shows everything hooked back up. You got the flex tubing there, you got the air lines, you got all the grading back up. So we're ready to turn everything back on and reprime the system. And that last day, again, we reprimed and we're back in operation on that 4th day. But on that 5th day was just minor site, cleanup. We did have a training from one of the manufacturer representatives. And again, that's when the project was completed. Everything was wrapped up, everything was done, and the plant was operating within the limits of how it should. So really, in conclusion here, I really want to portray that all the steps that we took as the MUA to evaluate the replacement in kind, any type of repairs that could be done with the existing equipment, all the cleaning procedures that were done prior to really evaluating really the most expensive option, which is this complete retrofit. So the retrofit of existing MBR equipment with Kubota equipment was feasible and cost effective with appropriate planning. So this all goes back to the original concerns we had with changing manufacturers. Utilization of the existing crane, utilization of existing penetrations, utilization of existing air supply and permeate piping, utilization of existing blowers. All of those were able to be accommodated. Then you have the operational improvements, limit the downtime, not just for the installation of this retrofit, which was just 3.5 days, but while we're in operation, once this project is completed, are we able to really disconnect each unit and pick it from flow if we needed to without isolating that plant? And then, are we able to optimize the cleaning system? We were able to do all that. Did it take planning? Yeah. Did it take a lot of, interaction between the MUA and Kubota? Yes, it did. But they were a great team in this to take kind of our wish list of items and really be able to accommodate every single one that we had. So like I said, all existing operational concerns were addressed in the retrofit to make operations easier for our staff. The total downtime was just, again, it was 3.5 days. And at the end of the day, I think we're very pleased with the proposal process, the construction staging and quality, as well as the current operation of the membrane system that was installed. So, again, this was installed last September. We're over a year, and everything has been working flawlessly, knock on wood. I know I probably shouldn't have even said that, but we have done the necessary CIP in accordance with the training and the O&M manual, not out of necessity due to the TMP or the permeability, but because basically that's what's the recommended duration in the O&M manual. So we haven't seen any type of decrease in permeability or increase in transmembrane pressure that would require it from that side of the fence. But again, this is the intent, is to maintain this system for at least its 10-year useful life. So that's the intent. So again, we're very pleased with the process, and we're pleased with how the current operation has gone. Just a quick special thanks to all my MUA operations staff. I mean, in terms of keeping the old facility or the old units operational for as long as they did is a real testament to them and their ability to operate the equipment. Kevin Crane, who again is the Northeast Regional Manager for Kubota, he was kind of instrumental through this process in assisting with this project and managing it through the kind of the infancy stage, with the understanding that he knew we were in a tough situation, that our backs really were up against the wall in terms of how our existing plant was operating, what our incoming flows were, the amount of hauling we were doing every day, every week. So he really understood that, which was again a great help. And his turnaround time it really made us feel like we were one of the only clients. And I know that he's a very busy guy, and I'm sure we're one of many. And then Kester Associates, who was the contractor for this project, they were recommended by Kevin, and he could not have been more right, in terms of how amazing they were throughout this process. So it is equally a shout out for them, as well as Kubota, in terms of really the overall process from start to finish, from the the retrofit design to the installation. So that kind of wraps up what I have to say here, and I'd be more than happy to kind of answer anyone's questions they have on kind of the process we went through as an MUA, and any other questions that anyone in the audience may have here.